In this video, I'll be explaining about steps in converting ER diagram to relational schema diagrams. So the topic heading is ER to relational mapping algorithm. So there are around 7 steps involved in this algorithm. The first step is mapping of regular entities. Second step is mapping weak entity types. Third step is mapping binary 1:1 relationship types. Mapping binary 1:n relationship types. And the fifth step is mapping 1:n relationship types. Sixth step is mapping multi-valued attributes. And the last step is mapping of n-array relationship types. So the first one is mapping regular entity types. First of all, we have to identify what are the entities in our ER diagram. So for each regular entity type, create a relation schema R and include all the simple attributes of E. And we have to identify any one of the attribute as primary key of R. So in this ER diagram, we have a regular entity or strong entity employee, department, and dependent. We have identified the regular entities. 3 regular entities are, that is given in the example, employee, department, and project are the strong entities or regular entities. We are not selecting the weak entity. So for each regular entity, so create a relation schema. Employee is the relation schema created, department is the new relation schema created, and project is the new relation schema created. Identify any one of the attribute as key attribute. So we have to identify the key attribute here. SSN is the key attribute in employee. Department number is the key attribute in department, and project number is the key attribute in project. You can observe here, I'm not adding any of the foreign keys or any other attributes. Simply I'm adding whatever the surrounding attributes that are represented in oval shape has been added here. F name, middle initial, last name, SSN, birth date, address, sex, and salary will be added with respect to employee. In the case of department, they have name, number, location that has been added. And the primary key is identified and it is underlined. So that is our first step, mapping regular entities. Second step is mapping of weak entity types. Identify the weak entity type W, create a new relation R for the weak entity. In addition, include as a foreign key attribute of R, which is the primary key attribute of the relation that corresponds to the owner entity. Now let us go to the ER diagram. Here is the ER diagram. We have to identify the weak entity. Which is weak entity? Weak entity will be provided with double rectangle shape. Dependent is the weak entity, which is the owner entity for dependent employee, and dependent of is the identifying relationship. We have identified the weak entity dependent. Independent, add primary key attribute of owner entity. Which is the primary key attribute of owner entity? SSN. Renamed it to, I have renamed it to ESSN. ESSN, and dependent name is the partial key. Sex, birth date, and relationship are the other attributes of dependent. So the combination of foreign key as well as the partial key will give us the primary key in dependent. So this is the second step. It talks about identification of weak entity types and then addition of primary key of the owner entity in weak entity type. So we have identified weak entity, created a new relation, and then added a primary key of owner entity and the partial key of weak entity, and we made it as a composite primary key. So the primary key of R is a combination of primary keys of the owner and partial key of the weak entity. So that's about step 2. Third step, mapping binary 1:1 relationship types. In our ER diagram, we have to identify 1:1 relationship type. So identify the relation S and T because 2 relations will be participating. So I'm calling one relation as S and other relation as T, corresponding to the participating entities in relationship type R. Choose S and include foreign key in S, which is the primary key of T. It is better to choose entity type with total participation in R in the role of S. First of all, we have to identify the 1:1 relationship in a ER diagram. Here is the diagram that helps us to understand this particular step number 3. 1:1 relationship type is managers. I will call this as S and I will call this as T, because department I am calling it as S because it is having total participation. So the same thing is told here. Choose one relation S, say include foreign key in S, the primary key of T. Choose in S in such a way that an entity type with total participation in R in the role of yes. I'm selecting department as yes. In department, I'm adding as a foreign key the primary key of employee tables. See, in department, MGR SSN is added here. MGR SSN is added here. Earlier in department, that attribute was not there. Department name, department number, department location was there. Right now I'm adding MGR SSN. How I got SSN? Because it has been added with the help of employee. Since there is a 1:1 relationship type, this is S and this is T. In S, I'm adding a foreign key, which is the primary key of T. Now MGR SSN is added. And also one more important thing here is that any of the attributes of 1:1 relationship type needs to be added in yes. The attributes of 1:1 relationship type is start date, and the start date is added to this department. So this is the relation schema after the step 3. Step 4, mapping 1:n relationship type. First of all, we have to identify 1:n relationship type in an ER diagram. Identify the relation S that represent the participating type at n side of the relationship type. So we'll go step by step. 1:n means, yeah, I do have two things here. Three things: supervision, dependence of, and works for. I'll take works for first. I have identified the 1:n relationship type in ER diagram. Identify the relation at n side. Employee is the relation at n side that we have identified. Include as a foreign key in S the primary key of T that represent other entity type participating in R. R is nothing but relationship type. Include in S. S means employee. The primary key of T in S. Now, which is the primary key of department? D number. In employee, we have to create new relation. Employee. In employee, along with the other attributes, I need to add the primary key of the department. So department number is added here. Okay. And we have one more relationship type here. That is supervisor. 1:n, which is at n side, employee only. In the employee itself, include the primary key of employee as a foreign key in employee itself. So super SSN has been added. It has been renamed. SSN means employee ID. Super SSN means manager ID. So two foreign keys have been added to employee because of 1:n relationship type. I have left with one more 1:n relationship type here, dependent. Now see, this is yes and this is T. The participating entity at n side is yes and this is T, and this is identifying relationship type R. Now in S, I need to add primary key of T. Which is the primary key of T? SSN. So in dependent, I need to add SSN. Finally, the dependent table looks like this. I'll take you to the particular. Sorry, I forgot to copy here. So for dependent, ESSN. See here I have copied. ESSN has been added, which is the foreign key. The final diagram. So I forgot to display here. So ESSN is added here. So that is your fourth step. Identify 1:n relationship type. Identify the relation at relation at n side, and for n side relation, are the primary key of T in yes. That's it. works for, supervision, controls are the three relationship types that represent 1:n cardinality ratio. Fifth step, mapping binary M:n relationship type. So now we have to identify M:n relationship type. So create a new relation S to represent R. So if there are any M:n relationship type, we have to create new relation. So identify M:n. We have only one M:n relationship type, that is works on. Create a new relation to represent R. To represent works on, new relation schema has been created, works on. So works on has been created. So we'll go through the next things. Include as a foreign key attribute in S the primary key of the relation that represent the participating entity types. As a foreign key, take the primary key of employee SSN. I have added here and I renamed it to SSN. Take the primary key of the project, rename it to project number, and make these two attributes as a primary key. It is a composite primary key. Composite in the sense more than one attribute will give us the primary key. So combination of ESSN and project number will give us the primary key. ESSN and project number is primary key of works on. Also, one more important thing is that we have to add any of the relationship type attributes in this new relation. Ours has been added here. So ours has been added. So that's our fifth step. Include simple attributes of M:n relationship type as attributes of S. So the example for this fifth step is works on. The primary keys of project and employee relations are included as foreign keys in works on and renamed to project number and ESSN. Mapping of binary M:n relationship step is over, and the next step is step number 6, mapping of multi-valued attributes. In an ER diagram, we have to identify a multi-valued attribute. Let's say, for example, that multi-valued attribute as A. For these multi-valued attributes, we have to create a new relation R. So let us go to the ER diagram later. Let me complete this part. The relation R will include an attribute corresponding to A plus the primary key attribute K as a foreign key in R of the relation that represent the entity type of a relationship type that has A as an attribute. So primary key of R is a combination of A and K. Identify any multi-valued attribute in the ER diagram. If you can see the department entity, we have location as a multi-valued attribute. So as far as the relational model is concerned, these multi-valued attributes are not allowed. Only atomic and single valued attributes are allowed in relational data model. So in order to avoid these multi-valued attributes, we can create a new relation. That's nothing but creating a new tables. We have to create a new relation. So add the primary key of the department in the department location as a foreign key and the department location as the multi-valued attribute. Now the combination of department number and the department location will give us the primary key. So the combination of department number and department location will give us the composite primary key. So in case of any multi-valued attribute, we have to create a new relation schema, add the multi-valued attribute and add the primary key of the relation that contains multi-valued attribute. So new relation has been created. So this is step number 6. Next is step number 7, mapping n-array relationship type. N-array is nothing but if the participating entities are more than 2, then those kind of relationship types are called as n-array. For example, in this case, all the relationship types are binary relationship types because only 2 entities are participating here. Employee works on project. Employee is one entity and project is one entity. So only two entities are participating. That's why these are all binary relationship types. Ternary relationship or n-ary relationship will look like this. Three entities will participate in relationship type. What are the three entities that are participating here? Supplier, project, and part are the three entities that are participating in supply relationship type. If we have any of the n-ary relationship types or ternary relationship types, what we have to do for this kind of situation? So if we can observe in our ER diagram, we don't have any n-ary relationship types. Okay, just in case if you come across with n-ary relationship types, you have to create a new relation S to represent R. In this case, supply is the new relation or table that will be created. For supply, include as a foreign key attribute in S the primary key relations that represent the participating entities. Now I'll create a relation called as supply. For supply, I will add supplier name, part number, project name, and also I will add any of the other simple attributes of supply in the relation. Now I need to create a table in such a way that supply is the table name, supplier name, part number, project name as a composite primary key attribute, and quantity as the simple attribute. And that is there. Also include simple attributes of inner relationship type as attributes of S. So that's it. All the 7 steps are completed. So just to give a quick recap of what are the steps. First step is, I'll just go to the ER diagram. First step is identify the regular entities, employee, project, department. Add all the attributes and then identify the primary key. That is first step. Second step, identify the weak entity. Dependent is the weak entity. Independent, add primary key of the owner entity. ESSN will be added. So I'll take you to the first diagram. Yeah, dependent. So this is added. ESSN is added. Third step, identify 1:1 relationship type. Identify the relation at total participation side, double line side. So department. In department, add primary key of employee. So MGR SSN will be added. Next step is identify 1:n relationship type. In n side, add primary key of department. So for employee, I need to add department number here. So final step. So this is the first step. No, that's why I have not added. Here I need to add department number. Next step is identify M:2N relationship type. Create new relation works on. The works on is not available here. I have to create one more new relation called as works on and then add SSN and project number and hours to the works on. Identify multi-valued attribute. So multi-valued attribute is department location. Create a new table called as a new relation called as department location. The attributes are department number and department location. The reason, relational data model do not allow multi-valued attributes. That's why we have to create a new relation. Last step is n-ary relationship. So n-ary, I have told you that if participating entities are more than 2, then it is called as n-ary relationship types. We have to create a new relations. So final tables that we can create using SQL are employee, department, works on, project, and dependent. That's it. In employee, along with these attributes, I'll get department number and supervisor super SSN. In department, along with these attributes, I'll get manager and manager start date because the start date is coming from this manager's relationship. In project, along with name, number, and location, I will enter department number. Department comes from this thing. See, this relationship type is represented as attribute in SQL code when we are representing in a database. And in dependent, we have ESSN, name, sex, birth date, relationship. The fifth table, additional table that will be created, even though if it is not an entity, that is works on because of M:2N relationship type. Works on, ESSN, project number, and hours. This table will give the details about which employee works on which project for how many hours. Employee Ram works on project X for 25 hours. Employee Ram on project Y works for 15 hours. If you have a restriction saying that employee should have to work for 40 hours. So these are the tables. So this is how you can convert an ER diagram to relational schema diagram, or you can also say it as converting an ER diagram to tables that you have to create. You have one assignment. So try to solve this assignment. We can discuss the answer for this problem maybe in the next session if possible. Here is an ER diagram. Convert or reduce an ER diagram given in the figure 1 below. What are the entities that are available? Manufacturer, part, customer, order. Since order is a weak entity, why? If part exists, then only order exists. Or if customer exists, then only order exists. Order number is partial key. Now you have to convert this ER diagram to relational schema diagram. So identify the regular entities 1, 2, 3. That is first step. Second step, identify 1:1 relationship types. Search for any 1:1 relationship type. No. Next step, identify 1:m relationship type. Two things are there. Identify entity at M side, part. Add primary key of manufacturer at part. Next, here also in order, add primary key of customer. Customer ID will be added. Customer ID, order number. That means this order is placed by which customer. Next step is identify M:1 relationship type. This is M:1 relationship type. Create new relation schema, that is contains, new table will be created, new relation schema, contains will be created, part number and order number, quantity. In order to give the representation about quantities, we want this table contains part number, this part, for this order this much quantities have been ordered. For part mobile phone, order number is 123, quantity is 20. Like this, contains new relation will be created. Identify for any multi-valued attributes, there is no multi-valued attributes. Okay, identify for NRA relationship type, there is no NRA relationship type. Obviously at the end, how many relations we have? Many are tables: manufacturer, part, order, customer, and then contains. Order contains customer, order contains customer ID and order number. So both will act as a composite. So combination of customer ID and order number will act as a primary key. So whereas order number is a partial key here. Okay, thank you. So that's the end of this session.